total solutions topic in the 12th class. So I'll try to explain in a chart mode. So total solutions we are going to classify broadly into three parts. So here is first introduction, methods of concentration of expressions, methods of expressing concentrations, like what? Percentage, weight by weight, percentage, volume upon volume, percentage, weight upon volume, molarity, normality, mole fraction, ppm. So those things first part we will do. The second part, solubility of solids in liquids, right? Solid in liquids, liquid in liquid, gas in liquid. The solubility is, so solid ni liquid lo add chesthe em avutadi, lekapothe liquid ni liquid lo add chesthe em avutadi, gas ni liquid lo add chesthe em avutadi, right? Idi discuss chestam మనం. And we'll discuss, here is Henry's law, Raoult's law, and ideal solutions and non-ideal solutions. Raoult's law, ideal and non-ideal solutions, azeotropic mixtures, and third part we'll discuss colligative properties. In the colligative properties, relative lowering of vapor pressure, then elevation in boiling point, depression in freezing point, osmotic pressure. So these, and ACP means what? Abnormal colligative properties. What is concentration? Generally what is solute and solvent? Which dissolves is solute, which on dissolution is takes place is we are called as solvent. So edaithe karugutado adi solute, edaithe kariginchukuntado, for example sugar salt undi, sugar water, sugar anedi solute, water anedi solvent, like that, right? Concentration ante enti? How much amount of solute present in the solution. Write it down. The amount of solute. Amount of solute present in solvent, or we could say solution. We call it as concentration. If it is less concentration, right? Less amount of solute. More concentration, more solution. If solvent is water, write it down. If solvent is water, aqueous solution. If solvent is alcohol, alcoholic solutions, right? Aqueous solutions and alcoholic solutions. So for example, this example, organic chemistry, which I'm relating, CH3CH2Cl, if I'm taking aqueous KOH, solvent is water, alcoholic KOH, right? Aqueous KOH, what exactly happens? CH3CH2OH. Here is alkene, write it down. Aqueous, this is nucleophilic substitution reaction, this is elimination reaction. Mean aqueous and alcoholic, the difference which I am telling you. So solution, solvent means constant largest, relatively small amounts, right? Homogeneous single phase, homogeneous solutions, first heterogeneous solutions we'll discuss. Homogeneous means all are in the same phase. Heterogeneous means all are in the different phases. Different means one is solid, one is liquid, one is gas, like that. Right? So I already discussed right now. Solvent is one is water, so homogeneous and heterogeneous things. So actually types of solutions: binary, ternary and quaternary solutions. Binary solutions means what? Only two components if they are present, right? For example, sugar plus water. Sugar plus water. Sugar plus water. So binary. Sugar plus water plus salt. Ternary solutions. Quaternary means four components, like that. Okay, just write it. So liquid solutions, gas in liquid, carbonated drinks, right? Liquid in liquid, alcohol in water, solid in liquid, so salt water. Solid in liquid, so I think no need actually. If you want, you can write the examples. Liquid in liquid, gas in liquid, right? Right. Percentage of concentration terms here. Percentage weight by weight, percentage weight upon volume, so percentage volume upon volume, right? So the amount of solute in grams dissolved in per 100 grams of solute, right? So percentage weight by weight of solute by 100 into weight of solution, right? Into 100 actually, 100 ikkada vastadi. So weight of solute by weight of solution into 100. So weight of solute by volume of solution into 100. Okay, 100 in ml. So volume of solute by volume of solution into 100. Okay, write it down. These three formulas. Percentage weight by weight, weight upon volume, volume upon volume. 100. Percent. ఎప్పుడైనా కానీ గుర్తుపెట్టుకో, percent అంటే 100 out of 100. Per cent means deci, centi, milli, micro, nano, right? Deci means what? -1. Deci. Centi means nothing but 100. అర్థమవుతుంది కదా? Centi like that. Right. So concentration terms: molarity, normality, mole fraction, strength, molality, ppm. So already I think I told you, right? So write it down. Strength of solution means the weight of solute present in liter. That generally strength of solution. Normally the weight of solute in grams per liter we called as strength of solution. Strength of solution. The weight of solute in grams per liter solution. Next, molarity, the number of moles of solute per liter solution, right? Number of moles of solute by volume of solution. So molarity is equals to number of moles V in liters of solution. So number of moles means what? It is very important. What is number of moles? Weight by molecular weight okatena, inka any other things? Mole. Actually mole concept is important. One mole is equals to if it is atom. Otherwise first it's a number 6.023 into 10 to the power of 23 what? Atoms or molecules? It can be anything, atoms, molecules, ions, or whatever it may be. Or one mole is equals to gram atomic weight. Atomic weight. One mole is equals to gram molecular weight. Molecular weight. So one mole is equals to gram molecule. Otherwise one mole is equals to STP conditions 22.4 liters. At STP conditions, write it on it. So for example, put a gram molecular weight on the. For example, 440 grams of carboxyl CO2 ఉంది. Right, how many moles? 10 moles. ఎలా చేస్తాం మనం? So 1 mole is equals to, right, 1 mole is equals to 44 grams, right? So otherwise ఇలా చేద్దాం. 44 grams కి 1 mole, 440 how much? means 440 by 44. So means from here we just derived the equation. This is given weight by molecular weight. So that's the reason always number of moles means what we will think that weight by molecular weight. But it's coming from here. But sometimes they'll give the atoms or molecules. So then we need to calculate the number of moles. Sometimes they'll give the volume. That also we can calculate the number. But always we'll think that molar number of moles means weight by molecular weight. That cases number of people are doing the mistake. Next. So molarity is equals to, right, N by V in liters. N is equals to, so okay, we'll take majority of cases weight by molecular weight. So molarity is equals to weight by molecular weight into V in 1 by V in liters. Numerator. So molarity is equals to weight by molecular weight into 1 by V in ml by 1000. So, but automatically we'll write up. Okay. So molarity is equals to weight by molecular weight into 1000 upon V in ml. What are the units? What are the units for molarity? Mole per liter. Mole per liter or mole per dm cube. Mole per dm cube. If I'm increasing the temperature, what about molarity? If I'm increasing the temperature, what about molarity? So temperature is directly proportional to volume. Temperature increases, volume increases. If the volume increases, molarity decreases because molarity is inversely proportional to volume. So decreases. So means molarity depends on temperature. Write it down. Molarity depends on temperature. Law of dilution M1 V1 is equals to M2 V2, right? If the same, for example, two same mixtures with different concentrations and different volumes, if you are mixing, so means, for example, so this dilution of law of dilution means adding the water. In this case, if I am taking, for example, 2 molar HCl 1 liter, right, plus 3 molar HCl 2 liters. If I am mixing, the volume we can say, because 1 plus 2 3 liters. But what about the concentration? Can we directly 2 plus 3 can we do? No. What is the formula? M1 V1 plus M2 V2 is equals to M3 V3. These are the initial, this is final. Write it down. M3 nothing but, M3 is nothing but what? M1 V1 plus M2 V2 by V1 plus V2, nothing but V3. For example, 980 grams of sulfuric acid present in 2000 ml or 2 liters. What is its molarity? So molarity is equals to 980 by 98 into 1 by 2. What? This is 10, right? 5 mole per liter. Mole per liter. Next, molarity is equals to N by V in liters, right? Number of moles is equals to, we can say, molarity into V in liters also. Okay, write it down. Number of moles. Number of moles. Number of millimoles. Millimoles is equals molarity into V in ml. Molarity into V in ml. Millimoles, number of moles. For example, write a question, 6.023 into 10 to the power of 20 urea molecules are present in 100 ml solution. 100 ml solution. What is its molarity? What is its molarity? Molarity is equals number of moles 10 to the power of minus 3. 10 to the power of minus 3 by, right, 100 into 1000, right? This will cancel 0.01. So like this molarity questions we will do. So next, what is molality? Number of moles present in 1 kg of solvent, right? Write it down. Number of moles of solute per 1 kg of solvent. Ikkademo solution, right? Ikkademo solvent. Solvent is very important. The number of moles present in 1 kg of solvent. So molality is equals to number of moles by kg of solvent. Molality is equals to weight by molecular weight into 1 by kg of solvent. Molality is equals to weight by molecular weight into 1000 by grams of solvent. The units mole per kg. If I am increasing the temperature, what happens? The molality remains same because here is no volume term. So it is independent of temperature. Independent of temperature. This formula is important to solve the numericals and is very important for colligative properties. This is very important for colligative properties because in the colligative properties we'll use molality. Right. Next, normality. So what is normality? Number of gram equivalents of solute by volume of solution. This is important, no? So for the normality, for pH calculations and all, normality is important. Normality is equals to what? Number of gram equivalents. Number of gram equivalents by volume of solution. Volume of solution in liters. So number of gram equivalents means what? Number of gram equivalents is equals to what? Weight of solute by weight of solute by gram equivalent weight. Gram equivalent weight. GEW, you can say. Write it down. So from above, we can replace this formula. Normality is equals to weight of solute by gram equivalent weight into 1 by V liters of solution. Gram equivalent weight. What is gram equivalent weight? So gram equivalent weight is equals to molecular weight, not weight. Right? Molecular weight by N factor. N factor for acids. So in this case, we can replace normality is equals to weight, given solution weight by, so this is gram equivalent weight is equals to molecular weight by N factor into 1000 upon P in ml. Write this formula. So is N factor for acids, for bases, for salts, for oxidizing and reducing agents in different cases. Well, for acids, right, molecular weight by, so number of H plus, number of replaceable H plus ions, number of replaceable or acidic nature or replaceable H plus ions. For example, HCl. So it is molecular weight by 1. H2SO4, molecular weight by 2. This is important. H3PO4, H3PO3, H3PO2. Right, H3PO4 molecular weight by 3. Here is molecular weight by 2. Here is molecular weight by 1. So why it is 2, why it is there is 1? 3 hydrogens unnai kada. Acidic hydrogen means what? Attached to oxygen. You need to know the structures. So these hydrogens we can't replace. Only what we can replace? These 3 hydrogens we can replace. The OH is directly attached with the oxygen. Those we can replace. Write it down. Next, for example, CH3COOH. 1. So these hydrogen only we can't replace these hydrogens. The carbon hydrogens are not that much of acidic because almost a similar electronegativity. For bases, so molecular weight by number of replaceable OH group. For bases, molecular weight by replaceable OH minus ions. Replaceable OH minus ions like NaOH, molecular weight by 1. MgOH twice, molecular weight by 2. AlOH thrice, molecular weight by 3. For salts, molecular weight by charge on cation or anion. Charge on cation or anion. NaCl, molecular weight by 1. MgCl2, molecular weight by 2. AlCl3, Al2 for example, Al2SO4 taken thrice. For example, AXBY. So n factor is equals to x into y. 2 into 3, 6. For oxidizing and reducing cases for OA and RA, oxidizing agents and reducing agents. Right, MnO4 is important. MnO4 minus in acidic medium. MnO4 2 minus MnO, acidic medium. Acidic medium. So what is its n factor? 5. It is plus 7 plus 2, right? N is equals to 5. MnO4 minus in basic medium. What is it? What is the compound? MnO4 2 minus basic medium. So plus 7 plus 6. MnO4 minus gives rise to a neutral medium. MnO2. So it is plus 4 plus 7 3. So this is very important to remember, like ban, BAN, ban అంటే ఏంటి? బ్యాన్ చేయడం. దేన్ని బ్యాన్ చేస్తాం మనం? 1, 5, 3ని బ్యాన్ చేస్తాం. ఏమి ఉండాలి? 143 ఉండాలి, రైట్? 153ని బ్యాన్ చేయాలి. ఇది ఉండాలి, ఇది ఉంటేనే మనుషులు ఉంటారు, రైట్? దేన్ని బ్యాన్ చేయాలి? నెంబర్ సిమిలర్ ఉంది కదా, సో బ్యాన్ 153. Got it? This is an easy way of, anytime, not now. For example, CR2O7, 2 minus gives rise to CR3 plus. It is plus 6, right? Plus 3. So, minus 2 అని కాదు, ఇక్కడ 1 mole తీసుకుంటే ఇక్కడ 2 CR ఉండే, కాబట్టి 2 into 3. Difference is 3 into 2. 6. ఫర్ ఎగ్జాంపుల్ ఒకవేళ 3 ఉందనుకో, 3 into 3. వాట్ ఇక్కడ నాట్ దిస్ వన్, నెంబర్ ఆఫ్ మాలిక్యూల్స్ పర్ మోల్ తీసుకుంటాము, ఎన్ని నెంబర్ అయినా కావచ్చు. ఫర్ యాసిడ్స్, ఫర్ బేసిస్ వాట్ విల్ డిస్కస్, ఫర్ బేసిస్ మాలిక్యులర్ G equivalent weight ఆర్ N factor, ఫర్ బేసిస్ మాలిక్యులర్ weight by for basis acidity, we could say acidity, right? Acidity, so acidity is equals to number of replaceable OH minus ions, or write it down. Acidity is equals to number of replaceable OH minus ions, or number of moles of H plus ion taken by 1 mole. Number of H plus ions, number of H plus ions taken by 1 mole. Number of H plus ion taken by 1 mole. Sometimes if there is no OH, like for example NaOH, KOH, those things are right. Na2O for example, Na2O, MgO. సో వీటికి ఎలా చెప్తాం? సో దీనికి ఫర్ ఎగ్జాంపుల్ H2SO3 వేస్తే, సో మనకి ఏమొస్తుంది? మనకి Na2SO3 plus 2H2, H2O. హౌ మెనీ H ప్లస్ తీసుకుంటుంది? ఇక్కడ 2H ప్లస్. Acidity is equals to 2. Acidity is equals to 2 because it takes 2H plus. It takes 2H plus. Na2O, ఈ ఆక్సిజన్ ఉంది కదా టోటల్, ఇప్పుడు మనకి H2O లాగా ఫామ్ అయింది కదా ఇక్కడ, అంటే ఎన్ని ఆక్సిజన్, ఎన్ని హైడ్రోజన్ తీసుకుంది ఇక్కడ నుంచి? 2 హైడ్రోజన్. అంటే టోటల్ Na2O అనేది ఇట్స్ ఏ బేసిక్ ఆక్సైడ్. Sometimes if we need to know Na2O, its N factor, right? If we want to know the N factor of Na2O, but there is no OH minus ions, how should we know? Right? When it's taking the how many H plus? It takes 2H plus, that's the its acidity is 2. For example, MgO, H3PO4. MgO plus H3PO4. So Mg3PO4, right? Mg3PO4 taken twice, and it is 3MgO, right? To H3PO3 plus 3H2O. 3H2O. I told you for the number of H plus ions taken by 1 mole. So 3 moles are taking 6 side. 1 mole, 2. I did 6 by 3. 6 by 3, 2. For acids, we can say, for acids, molecular weight by basicity. So write statement, one more statement. So basicity is equals to, I already told you, right? Number of H plus ions are given by 1 mole of acid. Basicity is defined as number of H plus ions are given by 1 mole of acid. Number of H plus ions given by 1 mole of acid. 1 mole of acid. Number of H plus ions are given by 1 mole of acid.